Ladies and gentlemen, my name is Dr. Sari. I'm in the University of Ghana, Legon. I'm a visiting professor in Warwick University in the UK and Stellenbosch University in South Africa. Okay. I'll be teaching you this course. And I have my research interest. That I engage in. And I want you to know the research interest because sometimes some of you might need it. Okay, some of you might need it. So one of my research interests is I use mathematical programming, linear programming, management science techniques to develop efficiency and productivity of institutions. I also use stochastic frontier econometrics. This stochastic frontier econometrics is a regression that I also use. That is, I'll be recording most of the lectures for you, and I'll be giving attendance. I'll be taking attendance in the middle of the course and in the end of the course. So even though I'll be giving you the video lectures, it does not mean that you have to miss the lecture. We are going to be torturing numbers, and they'll confess to anything. We will torture numbers. We will torture numbers, and the numbers will confess to anything. And that is the essence of this. Okay. So, ladies and gentlemen, once again, you are welcome to the journey through the valley of the shadows of management science. A little learning is a dangerous thing. This course, you either drink deep or you taste not the Pierian spring. There shallow drought will intoxicate your brain, and drinking largely sobers you again. What I mean is that this course, you are already committed. You have paid money. You are committed. Whether you like it or not, you are committed. And so you got to do everything possible to finish it with an excellent A. You deserve it. You've paid for it. You've devoted the resources to it, the time, the money. You can't let this thing go down the drain. So don't learn little. Drink deep. Drink deep or taste not. Or taste not. Okay. But once you're already committed, you want to drink deep, and I'll be helping you every step of the way. Every step of the way to get your A. But of course, it's always normally distributed, so some might not get the A, but just pass this course. Pass. Everybody should pass, and everybody will pass because of the systems I'll put in place. But you have to tap into the system to be able to do that. Turn off your phones. Turn off your phones or mute them. Don't put them on vibration. Mute them. Because the thing is that it's not going to help you at this very moment anyway. It's not going to help you. Okay? So turn it off, silent it, not even vibration, in order to understand this course very well. Email me if you early on have problems. I already have a WhatsApp group with you. WhatsApp me if you have a challenge ahead of time. Be warned that this course requires some thinking. And so just early on, if you are having some challenges, let me know. Okay. And I'll be having my surgical operations. Every doctor has a surgery. I do my surgeries at an arranged time, given the circumstances that we are in. So this assignment and participation, all of them have changed. The final exam now is the 30%, and the rest is the 70%. So the final exam is 30% and the rest is now the 70%. My teaching style is very interactive. So engage yourself. I give a lot of marks to those who talk a lot. And please, ladies and gentlemen, be of good courage. Be of good courage. You have conquered the course. I said you have conquered the course. Okay? It's not about amen. Okay? It's more about your to tap into that email. Some people defeat themselves when they quickly come to realize that this is a mathematical environment. I'm a very, very mathematical person, but I will be as very applied as possible. I will not bombard you with too much of the mathematics. Believe you me, I will go down to get the practical implications of those mathematics. So rest assured, be positive, and let me know what is working and what is not working for you. Put in the time and the energy. Anywhere is a walking distance if you have the time. You are going to constrain yourself because you may be a mother. You have the time to take care of your family. You have the time to work. You have the time to this. You have to... Okay, remember, this MBA course is supposed to be a full-time course. So if you are working, you have put yourself in a very compromising situation. So you need to put in the time. You need to put in the effort. You need to sacrifice. If you have been sleeping too much, this is not the time. Opele, this is not the time. The next 2 years of your lives are critical. They are critical. You don't want to mess up the time. Every time is a resource. Every moment counts. Every single second counts as far as you're concerned. You might put yourself in a lazy environment because of the corona situation, because you are working from home. If you don't, oh, I have the time. Oh, I have the time. Oh, I have the time. Hey, you ain't got the time. You need to put in the time, because time waits for no man. And so you want to put in the time, devote yourself to this, sacrifice some sleep for this. This is your world. You are the captain of the ship. Burn your ships. Be in control of this. You win is on you. You lose is on you. You are in charge. You are in control of everything as far as these whole courses are concerned. Okay, so now let's begin. What is management science? What is it? It's a quantitative approach using mathematical algorithms to be able to tackle real life situations. I'll be giving you practical examples of this. In the world of mathematics and statistics and operations, this is sometimes called operational science, decision science, or operations research. Operations research. It started in the World War II. During that time, the British intelligence, okay, and American intelligence has some scientists, and these scientists were asked to develop some military strategies, very powerful military strategies to deal with wars during the war. And after the war, the strategies that were developed became useful in the areas of engineering, manufacturing, transport, health, business, marketing, telecommunication services, and other areas of human life. Those techniques, ladies and gentlemen, are what we are going to learn in this very course. At each point in time when anything that I say is not clear, you have the opportunity to raise your hand using the icons, and then I will re-explain everything. Do not feel shy to ask your question by raising your hand. Do not feel shy to say, Doc, sorry, I didn't get this. Do not feel worried in doing that. This is yours. You are the captain of this ship. So demand it. You paid for it. So go for it. Okay? So do not hesitate to raise your hand at all to ask a question anytime. Okay. So let's look at some practicalities of management science. The practicalities of this course. How can a firm compete better than other people? How can EcoBank compete among the banking industry? How can the University of Ghana compete very well with other universities in Africa? How can managers decide well in advance, okay, in the presence of uncertainties, in the presence of coronavirus, what to produce and how much to charge? Okay. Should we produce more of Boeing aircraft? Should we produce more aircraft? Should we run the airline industry? How much money should we charge now? These are management science questions. How do we assign this task to the corporate manager instead of the production manager? How do we schedule the task with the CEO instead of the departmental manager? How do we manage the resources at our disposal? When you go to a university and people are registering, they queue. When people are engaging in elections and they are going to vote in an election, there's a long queue. When people are in a bank, there is a long queue. How do we reduce the queues? Because the more queues that build up, the more the likelihood of losing customers. Queuing model is one topic we shall learn, which is a management science technique, which will help us to better understand this situation. And so, guys, this is very practical. What we are learning here is not a joke. It is things that we face in real life. So those who are able to take this course very seriously, they become consultants, management scientists, strategic analysts. Okay, they are able to contribute beautifully in the establishment where they are working, and that managers are able to be so much, enthused about them, and they say, wow, where did you learn this? This is not very, very well known in every universities. Okay, and so very few universities are beginning to adopt operations research, techniques and management science techniques. Let me show you some award-winning applications of management science for you to just appreciate that this course is something that can help you. For example, there is a group of management scientists who are in American airline, organizations, and these people have used forecasting and optimization to model how to offer discount and full fares in their revenue management. So should we give discount? Should we give full fares? They were able to use optimization, and we shall learn optimization in this course. They were able to use forecasting. We are going to learn forecasting. And what was the benefit? They were able to make $1 billion in revenue, every year. That's how much they were able to make. They were able to make this amount of $1 billion just by adopting the forecasting and optimization models, which we are going to learn. So who tells you that management science is not an award-winning program? Now, in the South African Defense Force, they were able to use optimization to redesign the size and the shape of the defense force and the weaponry systems. This was in 1997. They were able to save $1.1 billion in South Africa just by learning the techniques you are going to learn. So who says management science is not very practical? It is practical. And so I want you to see the practicality of what you're about to learn. It goes beyond, just an academic exercise. Now let me give you a very practical one that you might even know. Let's assume that in your normal everyday living, you schedule a holiday. In London, you're going to London. Now, before you do that, you need to look for the airline, the flight. Okay? You need to look for a cheaper flight. So you use something we call Skyscanner or a Google approach of something, and you use it to book your flight. Now, what you don't know, or you might know, is that there was an algorithm developed by operations researchers. And this algorithm behind the scenes, you see, while the thing is saying loading, 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 that algorithm is searching among millions of options to find the cheapest airfare for you. It's an algorithm. An algorithm is a procedural analysis, a step-by-step procedure behind the scene. First step, second step, third step, and then eventually gives you the cheapest fare. There was another algorithm that will schedule the flight crews and the aircraft used by the airline. Another algorithm, if you rent a car in London, the price that you pay for the car, that London cabs, that price you pay on that meter reading is determined by a mathematical model. And that model seeks to maximize the revenue of the car rental company. This is management science. This is research. And this is what you are going to learn. So do not underestimate. This is very practical. You can apply most of the things you are learning here to real life situations. So let's start with one of the topics in management science. The first topic. There are quite a number of them, but this is the first topic we're looking at, which is known as linear programming. Now, the word linear programming comes from which word? Type it there. Which word? Linear programming. It comes from which word? Type it there, let me see. Linear programming. Linear programming. It comes from which word? Type it there, let me see. Linear programming. It comes from what? Linear comes from what? Yeah, I've got one type. Okay, I need more types. Okay, linear comes from what? Dennis Frempong, line. Theophilus, line. Ofosuhiman, line. Priscilla, line. Okay, this one you need to type. You don't need to raise your hand. Okay, and the reason, and that's right. Okay, that's correct. Okay, that is so correct. So it comes from line, and what that means, ladies and gentlemen, what this means is that we'll be dealing with lines. We'll be dealing with lines because linear programming is a mathematical programming approach that helps managers determine the linear relationship representing the decision of the firm, the objective of the firm, and the resource constraints that the firm is facing. This linear programming was first introduced, formalized, and applied in the world of economics in 1939 by Kantorovich. It was hidden from that time until George Bandic, okay, used a method known as the Simplex Method to deal with it. Now we will be using the Simplex Method. We'll be applying in the advanced management science. We do even the hand computation of the Simplex Method, but we'll be using the Excel. We'll be using Excel, and Excel Simplex methods will be working behind on the computer for us, and we'll be applying this using the Excel. So these are the people behind 1947. It all began there by Danzig. So what are the components of linear programming? I want you to please put these things down because we'll be coming back to them very soon. The components of linear programming. You need a decision variable. I want to repeat that. You need a decision variable. And let me share something with you, okay, on this screen. You need a decision variable. So look at the screen there. The decision variable could be something like x1, okay, x2, x3, x4, okay, x5, and then on and on. So we will refer it to as xi, okay, and the I is from 1, okay, all the way to, let's say, 6. That is if there are 6 of the x's. What is this? Is the decision variable. Okay, that is the decision variable. What is that? What is that? Okay, now let's say that you're a company and you want to produce something. That thing you want to produce, you got to decide on the number of how many of that you got to produce. That thing is a decision variable. Let's say that you are owning a stadium and you want to know, because the decision, you see, that thing, the decision variable is that thing that you need to control. You need to control in order to know how much you are going to earn. So if you are in a stadium, you need to control the audience, the spectators. How many spectators should you allow? How many seating capacity should you allow? That becomes a decision variable. Let's say you want to minimize some cost. Now, before you can minimize the cost, you are producing something. You are producing some shirts, some shoes, some trousers. But you got to know how many of the shirts, shoes, trousers do you got to produce so that you'll be able to make more money. So that thing you got to decide on, the item, the information content you got to decide on. That is a decision variable. Okay, so that's the first one. The second one that you need to identify, okay, the second one that you need to identify is known as the parameters. Okay, the parameters. Now the parameters will be represented by something like C1, C2, C3. So those are the price attached to that thing you're going to produce. The price. Okay, the price. So as an example, or the value. So it's either a benefit you will incur if you should produce the item, or a cost you will incur if you should produce the item. What is a benefit and what is a cost? Okay, so let's say that you are going to produce 20 of the shirts, and the shirt is being represented by, say, S1. Okay, S1, and want to produce 20 of the shirt. Okay, so now you have shirt, which is X1. Let's see how much is one shirt going to cost. So that one shirt is going to cost something like 20. Okay, it's going to cost something like 20. So you have 20 of the X1. Okay, so that 20 now becomes the value that you attach to the shirt you are producing. Now this 20 is for one shirt. Okay, so that is for one shirt. But you are producing how many of the shirts? The X1 will indicate the number of shirts you're going to produce. And so eventually, the total value you are going to gain from the shirt that you're going to produce will be the 20, okay, the 20 here, and then the shirt. And that will give you the total number of what you are going to produce, the 20 and then the shirt. So then we're going to do practicalities of all of this as we go on. Okay, for now, let's go back to our situation, the storyline. So you need to have that, and that amount you're going to produce is that. Now, the parameters we eventually, so now I spoke about the value. So the value could be the cost, the total cost. Okay, the value can be the total profit. Okay, or the price per unit of the items that you're going to do with. And the goal of this linear program, by the way, look at this. The LLP means linear programming problem. Linear programming problem. And linear programming problem, you always need an objective, which is the next one. The objective is either to maximize or to minimize. What is your objective? You want to maximize the number of audience in the theater. So that's your objective. Okay. Now, let me mention some objective. Then you tell me whether we are maximizing it or we are minimizing it. You can raise your hand. Suppose we are talking about something like the house price. You are a seller of a house. Okay, you are a real estate agent. And then the house price. What would you want to do with the house price? Maximize or minimize? You can raise your hand and tell me. Okay, the house price. What would you want to do with the house price? To maximize it or to minimize it? Raise your hand and tell me. Raise your hand and tell me. You don't have to mute yourself. You have to raise your hand. Okay? You don't have to unmute yourself. You have to just raise your hand and then you tell me. Okay, Bismarck.
Please, to minimize.
You minimize the house price as a sales agent.
Sales agent.
You don't minimize. Don't worry. Let's go to another person. And please use your actual name. Okay, Leonie.
So I think you maximize as a sales agent so as to improve your profits.
That's it. You got to maximize it. You got to maximize it. Let's talk about distance. The distance travel by a car. What would you want to do with a distance? What would you want to do? Abu Farid. Okay, Lewis Dampton. Lewis Dampton. What would you want to do?
So you minimize the distance.
Correct. You minimize it. You minimize it. Okay, you minimize it. Now let's look at another thing like the cost of employees. The employees cost. What would you want to do? Not you. I'm talking about the employer. What would the employer want to do with the cost of employees? What would the employer want to do with the cost of employees? Gifty. Cost of employees.
You minimize the cost.
You minimize it. What about the government budget? Government budget. Government budget. What would the government want to do with the government budget? This one is tricky. What would the government want to do? If you don't know, lower your hands. What would the government want to do with the government budget? And user J.
They want to minimize it.
Exactly. You want to minimize it. Okay. What about the revenue? Government revenue. Government people are speaking, so speak some. Opele, speak some. Give to you two. What would you say?
You want to maximize it.
You want to maximize the revenue. So see, there
Yes.
are certain things in life that you know what you're going to do with it. Now, the final thing in the linear programming are the constraints. Constraints. They are the restrictions. You see, anytime you want to maximize or minimize something, okay, there are certain things that are outside your control. Okay, they are there. You can't deal with them all through. They are there. You can't deal with them all through. And so what do you do with such things? Well, what you do is that you acknowledge them. One of the constraints is time. We all have 8 hours a day working, maybe an extra, by maximum of 24 hours. You can't do anything much. So you got to make good use of the available resource, because these resources are limited in supply and they are constraining you. Labor is limited. The materials that you're going to use to produce, the money, all of them. See, I'm a pragmatist, and the best way to best explain this linear programming is by giving you an example. How about an example? I'm going to use this example to get into the nitty-gritties of everything. So work with me. Work with me. This is an example. Let's look at it. Who will be ready to do the reading for us? I want somebody to do the full reading of this preamble for us. Who will raise a hand and do the read? George Doe. Please read for us.
Hello, Doc.
Go ahead.
Yes. Farmok Ghana Limited produces Fan Yogo and Fan Choco. Some Ghanaians love these. The two key resources used by the company are labor and milk. Given the limited resources, the company desires to know how many sachets of Fan Yogo and Fan Choco to produce each day in order to maximize profit. There are 40 hours of labor and 120 gallons of milk available each day for production.
Continue. Continue. We've not ended.
Fan Yogo requires 1 hour of labor time, and Fan Choco requires 2 hours. Also, Fan Yogo requires 4 gallons of milk, whilst Fan Choco requires 3 gallons. The profit from a sachet of Fan Yogo is 40 Ghana cedis per unit, and from Fan Choco is 50 Ghana cedis per unit. Formulate a linear programming model for this product mix problem and solve using graphical analysis.
Thank you. The key word is formulate a linear programming model. And that's what we are going to do. We are not going to solve it today. I don't want anybody to have a heart attack today. But then we'll formulate, because the most skillful skill needed is to be able to formulate the model. Now, this preamble that you guys are seeing, it reminds you of a storyline called word problems. Do you remember word problems in secondary schools? Or things related to simultaneous equation word problems. Do you remember such things like that? Simultaneous equation word problem. Yeah, something like that. But you see, if you want to look at this thing in totality, it's not a good way to start. Oh, what's all this? The whole thing looks Hebrew. Everything looks like Greek and Hebrew and Latin. I don't get it. It's because you're looking at it with a binocular. You got to look at it with a microscope. You got to peer slowly into it. And by the time you realize, you have been able to beautifully formulated this linear programming problem. So there are some criteria, some steps that I want you to get. I'm going to let you master this in toto, so that anytime you see something like this, you know how you are going to deal with it. I'm going to use my situation analysis here again. So the first thing I want you to do is this. Anytime you have something like this, remember that you got to deal with the objective. Okay, you got to create something we call the objective function. And the objective function is equal to the decision variables. Okay, the number of the decision variables that you have. So you have the decision variables, and each decision variable will be made up of the costs or the value, the per unit cost or the per unit value, okay, associated with each level of decision. Each level of decision. Okay, so I'll give you an example. So you have to first of all know this X's and then know this C's. Now the C's are the numbers that are given to you. They are the numbers, so you will know them because they are in the story. And then the X's are your decision. You will have to now represent some by X1, by X2, by X3, and as many of them. Those are the things you are going to produce, or the things you are going to sell, or the people you are going to manage, or the tax you are going to handle. Okay, so you need to be able to know how to formulate your objective function. We'll look at that. Now, in the formulation of the objective function, and please note it, you must have something like Z representing the objective. The Z can be the cost, it can be the audience, it can be the revenue, it can be the profit, it can be the, the spectators, it can be the distance, it can be anything. So the Z is the objective. And your goal is either to maximize or minimize. Now, so you normally write max at the bottom of it or min at the bottom of it. Now, you will not know whether it's maximize or minimize unless you read to the end, the storyline to the end. Okay. And that Z must be equal to the C1 that I spoke about and X1 plus the C2 and then X2 plus the C3 and then X3. All right. Okay. Depending on how many items you are going to deal with. Okay. How many items? In this case, what I've just written here simply means that I'm dealing with just what? Just 3 items. This one, that one, and then this one. Those are the items that I'm going to deal with. So that is the objective. After the objective, the next thing is to bring a symbol which is known as subject to. Subject to symbol. Okay. After the subject to symbol, then this column here, okay, let me just go back here and then show you something. Okay. So you have your Z, and then you have your, whether it's maximize or minimize. If you have a question, always raise your hand. And you have your maximize or minimize. Question. So it goes to C infinity. What is it goes to C infinity? Okay. Yes, it can go to as many as possible. Yes, it can go to as many as possible. I'm just limiting myself for you. So you can have X1. The number of X will determine the number of C's. Okay. The number of X will determine the number of C's. All right. So let's say that I've not written maximize or minimize because we don't know yet. So let's go. Okay. So once you write this, the next thing is to bring your equal to. Okay. And then with your equal to, you have C1, okay, X1, plus C2, and then X2. Let me just deal with just 2 variables. Now, then you have your subject to. The next thing you should have under this is that you should have a space here called one level, another space, and then a final space. Now, this first space is known as usage. I'm just giving you a guideline. Usage. We'll come to that. This is known as symbol. Symbol. And this is known as available. Available. I'll come to all of this. So, but for now, let's go back to the objective. How you are going to formulate the objective function. So let me go back to the storyline, and then Now, in this context, look at the storyline carefully. This is the beginning of the story, and this is the end of the story. What's the objective? What are we dealing with? Are we maximizing or we are minimizing? Who can raise their hand and tell me? Are we maximizing or we are? And you will see this in the storyline. Are we maximizing or we are minimizing? Okay. Andrews, maximizing or minimizing?
Maximizing profit.
Maximizing profit. Good. You've even added the objective. Okay. So the objective is maximize. How do you know that? You can see that from here. You can see that in the storyline. Now, ladies and gentlemen, let me just tell you something. It's not all the time you see the word maximize. Sometimes you will not see the word maximize. But you should know that when something is mentioned, it is going to be a maximize. For example, if I should mention the word cost, are we going to deal with maximize or minimize? Are we going to deal with maximize or minimize? If I mention the word cost, Louise.
Minimize.
Minimize. Louise, stay there. What about distance?
Minimize.
Revenue.
Maximize revenue.
Audience.
Maximize audience.
Vaccination.
Maximize vaccination.
Disease.
Reduce disease to minimize.
Good. Exactly. So at least you get a picture. So even though the word maximize or minimize will not be used, you guys will have to identify that, you know, theoretically or even practically, this thing is going to be minimized. Okay. So that is the first thing. So knowing that ahead, this is how you will now write your objective. You will now write your objective as Z max. Okay. Z max, like that. Z max. And then you bring equal to. Now let's go back to the story and then look at our decision variable. In fact, even before Z max, there's a first thing you want to do. Okay, let me just go back to the first thing. Let me just go back to that first thing. Let me clear this and then go back to the first thing. The first thing you want to do is to identify your decision variable, your X's, the items you are going to decide on. The items you're going to decide on. So let's go to the items. What are we going to decide on? What are the things we are going to decide on? Who can tell me? What are the things, the items, the decision variables? What are they? What are they? Always raise your hand is the best way I can see you. If you raise your hand using the icon, I'll see you because I don't actually see your faces. And the reason is because I'm sharing my screen. Okay. Gifty. Gifty. All right. Let's go to Bismarck.
Please, the products that are supposed to.
What are they?
That's Fan Yogo and Fan Choco.
Good. So that is it. Ladies and gentlemen, it's okay. Find yoga and find chocolate. That's all we need. That's what we are going to produce. We are not producing anything else. The only thing we are producing is fan yoga and fan chocolate. Okay. Now you need to write them and then mention the unit of measurement. No, so in this context, what is the unit of measurement for the fan yoga and fan chocolate? Always add the units of measurement. Atiemo, what is the unit of measurement? Atiemo Adam, what is the unit of measurement? All right, any other person, what is the unit of measurement? Sorry? All right, Atiemo, can you type it? Since I'm not getting you. Okay, type it for me.
The hours.
No, it's not hours. Atiemo, come again. Bertha, what is the unit of measurement?
Labor and milk.
Labor and milk is not the unit of measurement for fan yogo and fan. What is the unit of measurement? Let's go to another person. Rashida. Rashida too. Benedict, please mute yourself. Sulemana, what is a unit of measurement? Sulemana. Adam, what is a unit of measurement?
Sachets?
What is a unit of measurement?
Sachets produced.
Thank you. Sachets. Okay, sachets. Thank you. Okay. That is how it's
The unit
supposed
of
to
measure
be.
is sachets.
So that is a unit of measurement, sachets. Now, if I call you and you're not able to, get us, you can type the answer. Because some of you, your network isn't that fast enough to be able to. So yes, the sachets. So you always have to bring the unit of measurement, which is sachets, okay, in this context. So this is how you write it. X1 is equal to number of sachets, okay, number of sachets of fine yogo produced. Okay. Number of sachets of fine yogo produced. You have got to get that word there, produce, okay. And then X2 will be number of sachets. You have to write this. Write it in pen and paper. That's why I'm doing it. Okay. Number of sachets of fine choco produced. You have to write them down. So these are the units of measurement. Now, there are only two. That is why I've only ended at 2. Okay, that's the first thing you want to do. Okay. Now, you go and now write your objective. After this, if there are 3 of them, you've got to add all the 3 of them. Okay. Some hands are up. Yes, Anne. Anne, your question. Baldwin, what's your question?
Sir, please, since there are only
Baldwin, you sound far away.
yes, sir, please, I'm saying that since there are only 2, can we represent it by X and Y?
X and Y, I will advise you to use X1, X2, because as you go further, you come to later learn that we are going to deal with a lot of X's. In this course, you'll be doing a lot of X's. You even do up to X5, X6. Do you get it, Baldwin?
Yes, sir, I get it.
Okay. So let's start with that so that you don't get confused as we go further. Okay. As we go further, there will be a lot of X's we'll be dealing with. All right. So let's go to the objective. The objective is to maximize profit, and you see that in the storyline. Now, the objective will require that we now add the decision variables. If you remember what I showed you, add the decision variables to the unit. So look at the storyline. Okay, how many of the fine yogo? What to be the profit from a sachet of fine yogo? And what to be the profit from a sachet of fine choco? Because that single fine yogo and single fine choco, there is a profit attached to each one of them. And it is this profit together with the X1s and the decision variables is what I am going to write as my objective. So the next simple sentence is to indicate the Z. So you write Z max, we already know that is max, equals to something plus something. Who can give me that? Something plus something. What plus what? What plus what? You can tell me. Raise your hand and tell me. Nigel. Nagai.
The name is Nagai.
Yes.
It's X1 plus X2.
Okay. That is not the right answer. Let's go to Habiba. Habiba.
To be, yeah, no, 40 plus 50.
Good. Ideally, it would have been 40 plus 50, but the 40 plus 50 is the profit for yogo and choco. One yogo and one choco. So if we want to know the full yogo and the full choco, how is it going to be like? Okay. Let me go to Presla. How is it going to be like? Presla.
So it's going to be the 40. Yes, can you hear me?
I can hear you clearly.
Number of sachets produced for Fan Yogo by the profit plus the number of sachets produced
So
for
mathematically, how am I going to write that?
So it's going to be 40x1 plus 50x2.
Perfect. Excellent. No question again. Okay. So it's going to be 40x1. Now, why 40x1? Well, the x1 is the number of sachets of Fan Yogo. I don't know. I don't know yet. I don't know. Right now, as it stands, I've even represented it by x1. I don't know the value. If I happen to know the value, then I will know the total profit generated, because I know that the profit for one of them is 40. So if I want to know the total profit, because this Z is representing overall profit in the company, but the total profit for Yogo alone should be the single profit I get for one multiplied by the overall. It's like price times quantity. Okay, you remember the good old days of price times quantity in revenue, which gives you the total revenue. So that is the total revenue for Yogo. And then the same thing, the single profit I gave for producing Choco multiplied by the quantity x2 of Choco. And so that gives me x2. This is how you formulate the objective function. It is the most powerful thing you got to master to formulate. Your ability to understand the ingredients in here, because those ingredients in here are very, very important going forward. The ingredients in here, okay, they are very, very important for you to be able to move on as far as this is concerned. At this stage, is there someone who doesn't understand something? So you have 40x1 plus 50x. You got to plus it, because the Z is representing total profit in the whole company. Okay, the total profit in the whole company will be coming from what? It will be coming from profits from the Yogo, and then total profit from the Choco. And then you go to your subject to, which is the next thing. Always bring a dot. Okay, subject to. So let's go to the subject to. Let's go to it. So now I'm going to rewrite the whole thing again. Okay, so you have Z max equal to 40x1 plus 50x2. Now, and then of course you have your subject to. At this stage, you have to remember the next levels, and the next levels are called constraints. So what we are going to do is to write some things called constraints. And remember, I indicated what the constraints are. Okay, constraint. A hand is up. Yes, Priscilla, ask your question.
I just want to know what sign is there. Is it an SY or what's that?
This one is T. Is it that one?
Yes, please. Thank you.
All right, okay. So that's the subject to. Now the subject to, I told you that the first part, which should be on the same level as this. Okay, the first part should be called usage. Usage. Then the next part will be called sign. Sign. And then the final part will be called available. Available. If someone's hand is raised, okay, available. So let's pick them one by one. Okay, I want us to deal with the sign first. But before you deal with the sign, you got to know the meaning of the usage and available. Ladies and gentlemen, these constraints are resource constraints. Resource constraint. And when we say resource constraint, there are certain things you need to be able to do your business. The resources that you need to do your business. Now, these resources are there in the storyline. Which resources were mentioned? Who can tell me? What are the available resources that were mentioned in the story? Always let the story guide you. Always. Okay. Let the story guide you. Reginald.
Labor and milk. Labor and milk.
Thank you. Labor and milk. So the labor is in hours. The milk is in gallons. The labor is in hours. The milk is in gallons. Okay. Now, go back. Now, I want you all to relax yourself. If you have water beside you, take a water and sip. Okay. And you will notice something. Resources. Normally, what do we know about resources? We know that they are limited. Now, because resources are limited, once you know the available resources, what would you want to do? Would you want to use all of them? Or you want to use some of them? Who can tell me? Resources are limited. And because they are limited, once you have your available resources, once you know the exact resources available, would you want to use all of them? Or you want to use some of them? You want to use all of them, or you want to use some of them? Bismarck.
Certainly, since we want to maximize profit,
Just make it simple for us. All of them or some of them?
All of them.
Good. That's all I want. Okay, so we move on. I know that's the answer you have, but you want to be a news reader, a beautiful news reader for us. So you want to use all of the resources available. Now, because you want to use all of the resources, but is that normally what happens? In real life market systems, in real life, many people don't use all the resources. For example, many people go to the workplace, they're supposed to work 8 hours a day. And what happens? They don't use all the 8 hours. Some of them will start reading the newspapers, watching TV, and all of that. So you don't use some of the resources. All of you who have typed some, that is not the answer. You use all. Your goal is to utilize all the resources. Take, for example, the number of lecturers who are teaching you. These lecturers are resources the universities are using. That's it. The universities are using these resources, these lecturer resources, to teach you. Do you think that they would want to get all the lecturers to teach all the subjects, or they want some lecturers who will not teach some subject? Courses have been allocated. Lecturers have been assigned to courses to teach. And then each time you go to your class, in some of the classes, the lecturers are coming. In some classes, some of the lecturers are not coming. Is that going to be a beautiful story to tell? No. So you want to utilize everything because you paid for it. The resources have been paid for. You got to utilize, milk it. That is it. So, but of course, like we are saying, that is not what happens naturally. In real life, that's not what happens. And so in real life, some of the resources will not be used. Now, this symbol is very important. Now, I'm going to give you two symbols on the left here. Okay. The symbol is less than, greater than, and equal to. Which one will represent when all the resources have been fully utilized? All of them have been fully utilized. Which symbol? Andrew.
Equal to.
Which resources? Thank you, Andrew. That's correct. Which resources will be representing all resources? Only some of them were utilized. Not all were utilized. Okay. That gentleman with 216, you have to rename yourself. That way I can now approach you, because I don't like mentioning names I don't know. Okay, so rename yourself and use your actual name. Let's go to Theophilus.
Less than. Less than.
Less than.
Less than.
Okay, so that's correct, Theophilus. What would then be greater than? The greater than will represent what? Greater than will represent
when the resources exceed the work to be done.
The resources cannot exceed.
When there is a need for more resources.
There will not be a need for more resources.
Yeah, I'll come back
again. Yeah, I know. It wasn't meant for you, actually. It was meant for someone else. But let's go to Gifty. Yes, Gifty.
When buy more resources than you are supposed to buy?
Well, it just shows the unattainable resources. It's resources that cannot be obtained. So you can't have that symbol. You can't have the greater than symbol because that will indicate resources that cannot be attained. So this greater than symbol is not encouraging. It's not possible. It's not something that you will encourage it because you can't attain it. Okay, but this one is attainable. The rest are attainable. So our symbol will indicate less than, okay, but also equal to. Our symbol for labor will indicate less than, but also equal to. Our symbol will indicate less than and also equal to. Another symbol, if you look at the other one, that is milk. Milk. Milk will also, now why is it equal to? Equal to because it's possible that all the resources will be used. So when all the resources are used, then we have equal to. But it's also possible that some will be used and some will not be used. And so it means that there will be less than the available resources that will be used. And that is why milk will also be less than or equal to. So these are called resources and they are called resource constraints. Now sometimes you can have some constraints. Later on as you go further, you will learn about some constraints which are not resource constraints. They are called mixed constraints. Now let's go back to the usage and then the available. Now already by now you should know that available deals with the existing resources that the storyline gave to us. Existing resources. Existing resources. So what are these existing resources? Looking at the story, what are the available hours of labor and what are the available gallons of milk? Now you should always be looking for words like available, but it's not all the time you see that. So you should always be searching at the right way. Some of you are not really talking and they will realize that it would have been better they had spoken. Bertha. Yes, Bertha.
40 hours of labor and 120 gallons.
Okay. Now the person whose name
of milk.
Thank you, Bertha.
Hello?
Bertha, that's okay. That's fine. The person whose name is 299, type your name in the chat so that I can rename you. Because it appears that you don't know your name. You don't know how to do the change of name. So write it in the chat room. Write your name in the chat room so that I will use it to rename you. Isa, let me make you a co-host to be doing some of these things for me. Okay. So that person, rename yourself. Type your name in the actual chat. Okay. That person with 299, type your name in the actual chat and I'll use it to rename you. Okay. Do that. So the available are 40 hours of labor. And like I said, don't forget your unit of measurement. And 120 gallons of milk. And like I said, don't forget your unit of measurement, which is gallon. This left-hand side is in the storyline. It's in the usage storyline. It is telling you, even though this was what was available, how many was used to produce yogo? How many was also used to produce choco? That's what we're going to look at next. And that is a critical part. That is the most important thing. If you know how to model, then you would have been a master modeler. So let's go to the storyline. How many hours of labor? Okay, let me just go to how many hours of labor was used and how many hours of labor was used. How many hours of labor was used for fine yogo? How many hours of labor for use for fine choco in the storyline? And how will you write that for the whole of the labor constraint? Remember, we have the labor constraint. Let me show you. We have the labor constraint there. labor constraint here, and you also have the milk constraint there. So you're going to write the entire constraint for labor using the story preamble, and you see that you just have to open your eyes. So how many hours of labor was used for Yogo and Choco that we can represent? And remember, because we don't know the Yogo and we don't know the Choco, we must bring the X1 and the X2 in their representations. So who can formulate the labor constraint for me? Let's go to Theophilus. How will you formulate the labor constraint? How will you formulate? Oh, your hand was up. That's why I called you. If you are thinking about it.
No, sir. So I'm thinking about it. Let me.
Yeah, think about it. Just that next time you have to lower your hand, okay? Don't force to raise your hand. Baldwin.
Sir, x1 plus 2x2.
Baldwin, your voice sounds very far. Could you please come again?
x1 plus 2x2.
Good. I know what you mean by x1, but can you bring the number in front of it so that it sounds okay for those who are beginners?
1x1 plus 2x2.
That's correct. That's perfectly fine. Okay. So, ladies and gentlemen, if you look at the story, say fine Yogo requires 1 hour of labor time. So you need 1 hour to produce 1 Yogo. And then you need 2 hours to produce 1 Choco. Somebody has his hand up. Baldwin, is your hand still up? Otherwise, lower your hand for me, okay? All right. So let's write that in the labor constraint. So labor is going to be 1x1. I'm writing 1x1 for people who may not know fully, okay? And then 2x2. So 1x1 is actually x1. So it becomes x1 plus x2. And you can see that the x1 is following the objective function x1. And then the x2 is following the objective function x2 in that vertical fashion. If you organize it like that, it's always nice, okay, to organize it in that beautiful vertical fashion. Let's go to the milk, unless somebody has a question. Let's go to the milk. How will you formulate, again for x1 and x2, for Yogo and Choco, how will you formulate the milk? And look at the milk. It says that fine Yogo requires 4 gallons of milk. Fine Choco requires 3 gallons. How will you formulate this? Louis Damson. Louis Damson. Yes, go ahead.
That would be 4x1 plus 3x2.
Perfect. No qualms about that, okay? So that would be 4x1, okay, plus 3x2. So you've been able to formulate the usage, okay? Right now, we don't know the x1. We don't know the x2. But if we get, and that's what we're going to calculate. If we happen to get to know the x1 and the x2, you know what's going to happen? We would then have succeeded to know the actual usage of labor hours. Maybe the final answer will give us 40, giving us 40 left, 40 right. That is when the equal to sign will be. Or maybe the final answer will give us 30. So we'll have 30 left, 40 right. Oh, by the way, this left-hand side is known as the left-hand side. Okay, the left-hand side. And the right-hand side available is also called right-hand side. So please note that. We have the left-hand side and the right-hand side. Yes, Priscilla.
I'd like to know if we always should use the equal to, like less than or equal to, greater than or equal to. Do we always need to put the equal to sign in?
Not always. Most of the time, but not always. Not always, because as we go further, you see that some of the constraints will require that you have equal to. Some of the constraints will also require that you have greater or equal to.
Yeah. So I think my question is, when we are using the less than and the greater than, do we always need to use the equal to, just in, I don't know? Because we don't.
You don't need to. Don't worry, I'll get to a point where I will give you a typical details. Stand on and let me give you a typical example. When I say she is at least 30 years. She's at least 30 years. What is a symbol for at least?
Less than.
No, well.
Oh no, greater than.
Well, technically, it's not greater than. But I understand why you are saying greater than. Oh, by the way, unless you did a lottery, why did you say greater than?
If she's at least 30 years, it means she's more than 30 years.
She is more than 30, but you see, there is a word at least. The least part means that 30 must be part of it, isn't it? I should have said she's greater than 30.
Oh, okay. So it will be greater than or equal to.
That's it. It will be greater than or equal to.
So in this case, it will be greater than or equal to. Okay.
Correct. The same way, if you have at most 30, that will be less than or equal to. But let me give you a typical example of where. So again, you can see that if I had used a sentence which contains at least will carry with it the symbol called greater or equal to. And then at most will carry a symbol of less than or equal to. Now, I can also make a statement like she is not above 30. Let me write that sentence. She is not above 30. What would that symbol be?
Less than.
She is not above 30. If you take it literally, you will not get it. But let's take it one by one. What is a symbol do you think is for above? What symbol is above?
Greater than.
Good. So put that down. Greater than. Now let's make the sentence clear. Not above. What symbol is that? Not greater than will be what?
Less than.
No, that is English. We are talking about statistical and mathematical English. If you tell me that she's not above,
it could be equal to 30. She could
so
be
what would that be?
Equal to.
Yeah, so what would that be? Opposite of greater than will be what? Opposite of greater than will be what? You see, you've gone back to your English.
Less than or equal to, sir.
It's less than or equal to.
Okay.
Take your time and think through that. So these symbols, I'll devote some time for it. Okay, at appropriate time, and then give an idea. Now, so first thing, we have been able to formulate the objective function. Second, we've been able to write our constraints. In this context, the constraints are only 2. But please note that constraints can be a lot. As we go further in this, you get it. But there's one more constraint you are never told in the storyline, in the preamble to write, but you have to bring them. And that last constraint is always known as the non-negativity constraint. Okay, non-negativity constraint. What is that? Well, as it sounds very simple. The non-negativity constraint is that constraint that says that the decision variables, and what are the decision variables? The x's. Okay, the x's are the decision variables. These x's, they should be non-negative. In other words, they should be positive or 0. Okay, they should be positive or 0. So the first one is x1. So x1 must be positive or 0. Now, if something must be positive or 0, which of these symbols can we use for it? Less than, greater than, less or equal to, greater than or equal to, not equal to. Which one will be used to indicate that they should be non-negative? Okay, or they should be positive or 0. How would you have written it? Andrews?
Going to be greater than or equal to 0.
Yes, that's it. Okay, so you write x1, comma, x2, comma, okay, well, no comma because we have only x2, and then you write greater than or equal to. This constraint is called non-negativity constraint. Okay, non-negativity. You got to always bring. If you formulate any linear programming problem and without a non-negativity constraint, you have failed. You have failed. You have failed your entire formulation, because without a non-negativity constraint, there is no linear programming formulation. Now, at this stage, I want to now rewrite the whole thing again for you and ask you some questions. So you have Z max, which is equal to 40x1 plus 50x2. Andrews, hold on, I'm coming. 50x2 subject to, okay, and then you have x1 plus, that's the labor constraint, okay, that's the labor constraint, x1 plus 2x2 less or equal to 40, and then 4x1 plus 3x2 less or equal to 120, then your x1 comma x2 greater or equal to 0. This is your complete formulation. This is your complete linear programming formulation. Now, Andrews, you had a question?
Yes, sir. So, first of all, do you only state the non-negativity formula there? Just state it.
You must bring it always.
Okay. Okay. So that's the first one. Secondly, you said it means that the conclusion shouldn't be anything less than 0. It will always be greater than or equal to 0. I want to ask, is it the when you have to minimize when the Z is being in, not being max?
No, all the time. Maybe I need to teach you the intuition behind it. It will help you. You see, you are producing something, whether you are minimizing cost or you are maximizing profit or revenue, you are producing something. And that thing you are producing, you want a positive of it. You want to produce 1, 2, 3 continuous variables of it, or better still, whole integers of it. Now, the least you would expect is that you don't produce anything, which happens. In some companies, the first year, they don't produce anything. But you don't actually go with the intention that you are going to negatively produce. You can make a negative profit, which is a loss. You can make a cost, but you cannot produce something negative. It doesn't make sense. You get a point? It doesn't make production sense. Everything has been taught to you. So this is how you write your formulation. And in an exam, most of the times, I even let you write your formulation, your decision variables. So if there are 8 of them, x1, x2, x3, x4, up to x8, then you define each one of them. Don't forget the unit of measurement, sachet. And if it is in a different unit of measurement, kilograms, dollars, amount, blah, 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 you need to be able to know clearly. Then your objective function and all of that. I want you to look at this. This is your, all of the symbols I spoke about. Why is the sign less than or equal to but not equal to? And I indicated because the 40 hours of labor and the 120 gallons of milk are the maximum that can be used, but not the amount that must be used. Okay. And I asked the question, can a company produce more? I'll come back to all of this. But I want you to look at this. This is a complete formulation in your slides. This is a complete formulation in your slides. And I want you to look at this complete formulation because I'm going to ask you some questions based on this complete formulation. Okay. And the first question I want to ask you is this. I want to ask you this question. Okay. Looking at this formulation here, and then knowing where everything, please, if you have not written this, write it now. Because I'm expecting that you'll be writing throughout the process. But if you haven't written this, write it now. The first question I want to ask you is this. How many resources are there? And are they all limited? Who can answer that? How many resources are there? And are they all limited? Raise your hand and let me know. How many resources are there? And are they all limited? Luis.
So there are two resources that are there. That's the net and the labor.
Uh-huh. Are they
Yes,
all?
and that is all limited.
Yes. Okay, that's fine. Let's go to my next question. My next question. How many hours of labor are required to produce fan yogo? I'm going to go to your storyline. How many hours of labor are required to produce fan yogo? Now, this is what I mean. How many overall hours of, how many hours of labor are required to produce how many hours of labor are required to produce all of fan yogo? So who are the answer for me? This one has to be quick. Reginald. Sorry? Reginald, I couldn't hear you. Okay, Reginald, your sound is not good. Luis. Luis.
1 hour for fan yogo.
Linton. Linton.
Say.
Go ahead and
Hello, sir. Can you hear
your
me?
hand is up, right? You are ready to answer, right?
Yes, sir.
So that's why I called you. You are also asking me, yes, sir.
Yeah, 1 hour.
Okay, so 1 hour is wrong. Okay. Remember the question I said, how many hours of labor are required to produce all of fan yogo? Bordeaux.
If
It's okay.
fan
Don't
yogo,
justify. I'll come to the justification. I just want the answer. Yes.
24.
No, you can't get the actual number. You can't get the actual number, so it's not 24. Priscilla.
X1, please.
X1 is the right answer. Priscilla, can you make it specific?
Sorry, one X1.
Good. It's 1x1. Okay, it's 1x1. Now, ladies and gentlemen, let me just share something with you. You got to be following what we are doing because these are my questions I normally ask. Okay. Look at the storyline. Okay. Look at the storyline for this. I couldn't rewrite because the thing went up. So this is Z max equal to 40x1 plus 50x2. And this was subject to certain constraints, and the constraints were 1x1, I'm bringing this for a reason, 2x2 less or equal to 40. And then 4x1 plus 3x2 less or equal to 120. And then you have your x1, x2 greater or equal to 0. This was a formulation. And I was asking you this question. Okay, this was a question I was asking you. I said, how many hours of labor are used to produce fan yogo? Fan yogo is x1. And we know that x1, to produce even one x1, you need 1 hour. But to produce all of x1, you need the whole of this. 1x1 to produce all of it. That is the total hours you need to produce the fan yogo. Okay, that is the total hours you need to produce the fine yoghurt that we are talking about. Okay. Now let's go to this. How many gallons of milk do I need to produce fine yoghurt? Given this understanding, how many gallons of milk do I need to produce fine yogurt? How many gallons of milk do I need to produce fine yogurt? Give T, O2. Give T, O2.
No, that's the guy.
4x1, please.
4x1. How many gallons of milk? Habiba, stop writing the answers there, because if I really want you to write, I'll let you write. Because once you write, you confuse people from thinking. And I want people to think. So if you want to write personally to me, if you want to private chat me the answer, that's fine. But please don't put it in the whole group. Okay. So how many gallons of milk are used to produce fine choco? That's my next question. How many gallons of milk are used to produce fine choco? The whole of fine choco. How many gallons of milk? Reginald. How many gallons of milk are used to produce?
4x1.
Sorry?
4x1.
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 That's wrong. Let's go to Nagai. How many gallons of milk are used to produce fine choco?
It's 3x2.
It's 3x2. That's the right answer. Okay. 3x2 are used to produce fine choco. Why? Because if you look at fine choco, x2 is representing fine choco. And this is the whole of it. That is the whole of gallons of milk. Actually, the gallons of milk used to produce one fine choco is 3 gallons. But then the total gallons of milk used to produce fine choco is 3x2 gallons. If we happen to know the x2 variable, we multiply it by 3 and we know the actual number. That's how it works. That's how it works. Okay. Any question on this? Any question on this? Now let's go to the next question. What is the total gallons of milk used in this company? What is the overall, the total gallons of milk used in this company? What is the total gallons of milk used in this company? What is the total gallon? I say you either private chat me or you don't put your answer there. Okay. Let's go to Francisca. I think you are wrong.
4x1 plus 3x2.
That is a correct answer. 4x1 plus 3. I didn't say the total gallons of milk available. That is 120. But that's not what I said. I said the total gallons of milk. Okay. The total gallons of milk used. The total gallons of milk used in the company. That's what I said. So what is the total profit made in this company? And this is thinking. What is the total profit made in this company? Who is thinking with me? What's the total profit made in this company? Gifty.
Okay, that'll be 40x1 plus 50x2.
Excellent. No question about that. That's the best answer. Okay. That's the total profit made in this company. And what is the total labor hours used by Farm Milk Ghana Limited? What is the total labor hours used by Farm Milk Ghana Limited? Bismarck. 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 Okay. All right, let's Michael Kwaku.
Say I think that one would be 1x1 plus 2x2.
That's the correct answer. Okay.
Yeah.
Ladies and gentlemen, you got to know, it's not a matter of formulating the model, it's more of what? Understanding what you have formulated. because it can be. Now let me trick you finally. This is a final trick, and let me see anybody who can crack it. Is a note to that person for me for 2 marks. Okay. Let me trick you. What is the total labor hours used for the production of fan choco and the gallons of milk used for the production of fan yogo? What is the total labor hours used for fan choco production and the gallons of milk used for fan yogo production? You are either in or out. Andrews.
So it is 2x2 plus 4x1.
That's wrong. Okay, that's wrong. Who can tell me the answer? Habiba.
One x1 plus 3x2.
That's wrong. Next person.
5s1 plus 5s2.
Let's go to Matilda.
It's 2x2 and 4x1.
Excellent. Matilda, that was an excellent answer. It is 2x2 and 4x1. It's not 2x2 plus 4x1, which is what Andrew said. Andrew, do you understand why I said yours was wrong?
I was still wondering.
But do you understand now?
Yes, I do.
Because you cannot add them, because one is labor and the other is gallons. Okay. But what you can do is that, okay, you can separate them, because I was asking you to total for this and total for that. Master these things. Master these things. This is how you got to restructure yourself as far as this course is concerned. Okay. Bismarck, I just want to believe that your hand is not up. It's just mistake. Okay. So, ladies and gentlemen, the way you treat, yes, Bismarck, your question. Bismarck, your question.
Yeah, sorry, my hands was up.
Hey, have to always correct people to bring their hands down. Always. Okay. So this is where we end our lecture. So we've been able to get to the point here where we've formulated our results. Now we are left with 3 things. 1, we are going to solve this whole thing, because our goal now is to find how many fan yogo was produced, how many fan choco was produced. How do you solve it? We are going to solve that by graph. We are going to solve that by the simplex method. And we are going to use computer, Excel, to solve that. So next time, that's what we're going to do. We're going to do all these 3. So when you are coming to this class, have your laptop in front of you. Have your laptop in front of you. And try as much as possible to now go through the process of installing or invoking something we called the linear programming app. Okay, the Simplex app. What's the name? You need to invoke it in your Excel. You need to go to data analysis. Okay, and then you look out for analysis 2-pack. Let me see if I can quickly do this with you, because you need to be able to get that before coming. Okay. First of all, open your Excel like just have done, and then go to data analysis. Go to data analysis. So let's say I've typed something. Go to data analysis. On the far right, look for analysis 2-pack. It's not there. So that means that it's not been invoked. So to invoke it, go to File, choose Export. Sorry, choose Options. And a pop-up will come. And in that pop-up, select Add-ins. And in the add-ins, choose Solver Add-in. Solver Add-in. That's what you want. Solver Add-in. And then When you click on solver add-in, select go at the bottom. A pop-up will come. Then you tick solver add-in. It will not be ticked, so you tick it. Once you tick it, you click OK. Okay, you click OK, and it is done. Once you click OK, it means that it should be showing. So now you go to, once you come back to your situation, you go to Home tab, Data tab, okay, and then you look for solver add-in. That's it on the far right. Mine is using a question mark. Okay. The mine is using a question mark, but you can use that. You can change the question mark. Okay. But that's it. The question mark with an arrow, that's the solver add-in. The one on the top is the data analysis tools. But what you want is the solver. We are going to use this solver add-in to run the whole thing. And that's why you see the Simplex method in the list. We'll be working with that Simplex method. So try and go to your Excel and go through the process of file, options, add-ins, select solver add-in and click go, choose solver add-in and click OK. That's it. Okay. And that will be able to help you to deal with the solver add-in.